All right, so we are doing our crash review on mole calcs. So what I want to do, I'm just going to draw a little picture here. This is something you don't necessarily have to draw, but it'll help us kind of get in our head what kind of stuff we need to focus on for mole calcs. Okay, so when we start our calcs, we always are concerned with the moles. So this picture I'm drawing right here, I call it Demo's world. It's really not my world, but I like to pretend. This in the center is Mole Town. Okay, Mole Town's a pretty nice place. Kind of reminds me of Westlake. Simple place, not a lot of stuff going on, not too hip happening, but pretty important to the world around. Outside of Mole Town, we have a place called Grahamland. Grahamland has a bunch of rolling hills, all that kind of stuff. So if I want to go from Mole Town to Grahamland, can anyone remember how we did that? Moles to grams or grams to moles? What do we use? Yes. Close. That's a different place that we go to, not quite mole. So Lincoln said formula mass. There are many names for that: molar mass, gram formula mass, average atomic mass, all that. So how do we find the molar mass of a substance? Go to the periodic table and add them up, right? What are the units? So say water, we know water has about a molar mass of 18. 18 what? What are the units? Grams per mole. That is crucial. Molar mass is grams per mole. What does that mean? If I have 1 mole of a substance, if I have 1 mole of water, it's about that many mils, it weighs 18 grams. When I say I have 1 mole of water, though, how many water molecules is that? One mole. What is a mole? Oh, children. 6.02 times 10 to the 23rd. If I ask you what a dozen is, would you hesitate? No. So why are you hesitating when I ask you what a mole is? All a mole is a quantity. It's a number of things. So turn around and look behind you. See that number back there? That is a mole. 6.02 times 10 to the 23rd. Okay? So if I have 6.02 times 10 to the 23rd water molecules, that weighs 18 grams. So that's why on all our molar mass substances, so all molar mass units, we have to have grams per mole. There's another unit we'll talk about later called atomic mass units. That's based on the whole weight of a proton and a neutron being 1 AMU, and that has a literal mathematical conversion to kilograms, which you're going to talk a lot about in physics, and we'll use it here a little bit as well. We'll actually talk about it on Monday when we do some average atomic mass stuff. But anyway, if I am converting from moles to grams, I'm going to take the gram formula mass bus. That is the conversion back and forth from grams to moles. And again, the units on this are grams per mole. Okay. There's also a place I can visit, hip happening, awesome, Particle City. Particle City is converting moles to things like atoms or molecules, depending upon what we're converting moles of. So in doing so, if I do that conversion, what number do I use? Avogadro's number. So what we do is I call this the Avogadro's Express. Avogadro's number is 6.02 times 10 to the 23rd. There are that many particles per mole. And I say particles because it could be atoms, it could be molecules, it could be trucks, it could be buses. A mole is a set quantity. Okay? Another place which I'm going to change the color. We don't visit there right now, but we can get to Volumeville. It's farmland. It's the country. Volumeville. If we're at STP, does anyone remember how we get from moles to volume? Come on, first period was all over this. You guys know this. Yes, I hear it. Close. Not 24, 22.4. 22.4 liter tractor is what's going to get us there. It's a big tractor. How do you spell tractor? That? Does that look right? All right. There's a 22.4 liter tractor. What that means is a mole of the gas at STP is always 22.4 liters in volume. We're not going to worry about volume. Now, why am I showing you this stupid mole town? Who cares? Well, this is just kind of helping us remember that if we're going, for instance, from grams to particles or grams to atoms, can we get there directly? Nope, we always got to go through moles. So just remember your conversions back and forth. So I'm going to take you toward the end of the packet. I believe it's on page 15. If you recognize these pages, these are pages taken straight from pre-AP chemistry. So you have actually done these before. I'm going to do a couple problems on each page, and then I'll show you how I expect you to be able to do it in AP Chem. I'm literally only doing 2 or 3 of these because of time, but I think you'll be fine. So let's start out with number 2. Number 2, what is the weight? When I ask what is the weight, what am I looking for? What is the unit on that? Grams. So I am looking for grams. I always want you to somehow indicate in your problem what you're looking for. That way you don't have to go back and reread the problem 87 times to try to figure it out. So we're looking for grams, and our given is 4.50 moles of, this is where you have to know your nomenclature. What is barium sulfide? BAS. If you didn't know your nomenclature, you might really mess that up and get a wrong formula mass and so forth. All right, so barium sulfide in moles, I want to go to grams. I'm going from mole town to gram land. How do I get there? Molar mass, right? So anytime I do my conversion, it's always per 1 mole. So I heard someone say that. 1 mole of BAS we're going to put on the bottom. Let's find the molar mass. As a class rule, folks, always round to 2 decimal places. On the AP exam, the entire periodic table they give you, every single value has 2 decimal places. So I want you to use that in its entirety on the AP. Since this one goes out to 3, some do, some don't on this chart. Let's everybody as a class rule round to 2 when you're throwing out answers at me. So because of time, I need y'all to hustle. Someone, what is the molar mass? 1 what? 1.40 grams of barium sulfide for every 1 mole of barium sulfide. Moles of barium sulfide cancel. We only base our sig figs on the given value. We arbitrarily decided to round that molar mass to 2 decimal places. Why would I use that as a term of significance? It's not. So go ahead to 3 sig figs, tell me this answer. 762 units, grams of barium sulfide. Okay? I do want to do number 3 because I think it's an important example. How many molecules are in 28.6 moles of nitrogen gas? So we have 28. Uh-oh, do you see anything here that might be important? What can you tell me about nitrogen? It's a diatomic, so we have to have N2 here. Let's talk about the diatomics. Let's review them. Diatomics are I, Br, Cl, F, O, N, and H. What was our saying? Good. I bring clay for our new house. Some people out there teach Brinkelhoff. Some people out there say there's 7 of them in the shape of a 7, not including the hydrogen. I don't care how you know it, but I tend toward the I bring clay for our new house. That's been a Westlake thing for a while, so most of the teachers will teach it that way. So we're in moles of N2. I want to get to molecules. That's what I'm looking for. I'm in mole town, want to go to particle city. How do I get there? Multiply by 6.02. So if you're like, multiply or divide, you don't have to think about it. Write it down. I'm going to be pretty insistent you guys write it down and make sure your units cancel, because if you don't do that, at some point, you're going to make a mistake and flip it in your head. I know some of you are trying to be bad, and I'm awesome. I don't need to write anything down. Well, sometimes you do, and I know I still do. So every 1 mole, I have 6.02 times 10 to the 23rd molecules. For molecules, I write mole with a C, but if you want to write out molecules, you can. This is going to be our answer to 3 sig figs, but before you give me an answer, what if I continued this question? I said, how many atoms of N? What would you do? Multiply by 2, and I do that by saying for every 1 molecule of N on the bottom, I have 2 atoms of N on top. But that's not the question, though. So the 3 sig figs, what'd y'all get? And this is also another good indication that we're on the right track. If an answer is asking for molecules or atoms, you better have a big number like this. See how big that number is? That makes sense. If the question's asking for grams, that kind of makes sense, right? But if the question were asking for atoms and you got an answer of 0.5, does that make any sense at all? Okay, so just stop when you're done with the problem and ask yourself, does that number make any sense whatsoever? Okay, so check for the magnitudes of your numbers. So let's pop down to number 6. I'm trying to watch the time here super close. All right, how many atoms of oxygen are in 2.5 moles of oxygen gas? What can you tell me? There's a little hint there, diatomics. So we're looking for atoms, but we know that oxygen is actually O2 as molecules. So we have 2.5 moles of O2. When I multiply by 6.02 to get to the next level, what am I actually calculating? Molecules. So for every 1 mole of O2, there are 6.02 times 10 to the 23rd molecules. Now how do I get to atoms? For every 1 molecule, I have 2 atoms. Okay, so it looks to me as if this is a 2 sig fig answer. And what do we get here? And don't forget, gotta have units. Atoms of O. Good? Yes, ma'am. Well, because they're asking for actual atoms, you would write O. If they were asking for molecules, you'd write O2. And I know this kind of makes some of you uncomfortable even writing O by itself, and I get that, and this is not going to be something that happens very commonly. It's literally only in these dimensional analysis problems that we talk about it. And then when you get to organic, we do mechanisms with free radicals, and sometimes you'll see them as well. But you never will use them. Okay, this is just a math thing we're focusing on. So let's go to the next page and try some 2-step problems. All right, let's go ahead and do number 5. And the reason I want to do it is because I want to talk about a little bit of a terminology issue here. Number 5 says how many molecules are in 198.5 grams of sodium chloride. This bothers me just a little bit. The word molecule does. Can anyone tell me why that bothers me? Yes, Winborn. Okay. Well, molecule does imply a compound, but what kind of compound does the word molecule imply? A covalent compound, and that's what bothers me. When you have salts like sodium chloride, think about it in your hand. What does it look like? Sodium chloride in your hand. Crystals. They're crystals, right? So you can isolate one crystal, can't you? Do you think that one crystal is just an Na plus NaCl minus, and that's all that's in that crystal? No. So what's happening with these molecules, and we'll talk about it more when we get to bonding, this is a lattice, and there's all different Na and Cl and Na and Cl and Na and Cl, all electrostatically attracted in the form of a crystal. All right? So a molecule implies that it's just Na and Cl and that's it, and that's not the case. So for ionic compounds, we actually call them formula units. So one formula unit represents that one ionic relationship within the crystal. I'm splitting hairs here, but it just bothers me because it's not a molecule. A molecule is CO2. A molecule is H2O, all that covalent stuff. So to make it short, we're going to call it FU, formula units. And hopefully people won't think that I'm saying something nasty. So how many formula units are in 198.5 grams of sodium chloride? So we're looking for particle city. We're going to particle city here. 198.5 grams of sodium chloride. Okay, I'm in gram land. I got to get to particle city. Where do I have to go? Through mole town. I got to get to moles first. So for every 1 mole of NaCl, how many grams do I have? 58.44. 58.44 grams. All right, my grams cancel, putting me in moles of NaCl. Now, how do I get from moles to particle city? Avogadro's number. For every 1 mole of NaCl, I have 6.02 times 10 to the 23rd formula units. So for sig figs, go ahead and calculate that for me. .04. There's got to be an exponent, folks. 10 to the 24th formula units. Okay? I'm going to jump to number 8. Before I go, though, is everybody okay with that? Questions? All right, number 8. How many atoms of aluminum are in 2 moles of aluminum fluoride? So I'm going to start with 2.00 moles. And what's the formula for aluminum fluoride? AlF3. All right, we're going to convert then from moles to particle city. So it's a one-step problem. But when I use Avogadro's number here, what am I actually finding? For every 1 mole, or formula units actually, but yeah, for every 1 mole, I have 6.02 times 10 to the 23rd formula units of AlF3. Is that what the problem's asking for? No. They want to break it down even further and say, how many atoms is this? How many atoms do I have in every one of those formula units of the aluminum? 1. For every 1 atom of, I should say it the other way, I should say for every 1 formula unit, I have 1 atom of Al. What if I would have been looking for fluoride? It would have been 3 to 1. Okay? So go ahead and tell me we got 2 sig fig action going. 1.2 times 10 to the 24th. 24th. Does that number make sense? It's a big number. Is it? Yeah, it's 3 sig figs. How many is it then? 1.20. Is that what it was, or did you all just throw an O on? That's what it was? Okay, good. Good to know. All right. Last problem I want to do is number 10, and then we're going to go and look at it as you'll see it on your exam. Number 10. How many moles of carbon are in 1 times 10 to the 20? Is that an 8? It's just 20? Okay, I can't read it on this thing. All right, so I'm just going to work it up here. How many moles? I'm looking for moles of carbon, just carbon, are in 1 times 10 to the 20th molecules of propane. So I've got 1 times 10 to the 20th molecules of C3H8. All right, there's a couple ways you can do this. I like to stay I like to go immediately to moles. And I'm going to do that, but then down here I'll show you there's another way you can do it and get the exact same answer. So I'm going to take this to moles. So for every, how do I get from molecules to moles? Avogadro's number. So for every 1 mole of this, I have 6.02 times 10 to the 23rd molecules. And this is moles of C3H8. Okay, so my molecules cancel. Now I want to get to moles of carbon. And this is the relationship that I think that's really important you understand. If I have a mole of cars, automobiles, how many moles of steering wheels do I have? 1. If I have 1 mole of cars, how many moles of tires do I have, not including the spare? 4, right? So in addition to this 3 and this 8 being a ratio of atoms, it's also a mole ratio. Okay? So knowing that, I'm in moles of propane here. I want to get to moles of carbon. For every 1 mole of this propane, How many moles of carbon do I have? 3 moles of C. So to 4 sig figs, what did y'all get? No, I'm sorry, I'm looking at the problem above. I need to cross that out. That's just been throwing me off. It would be 3 sig figs times 10 to the negative 4 moles. And we can have moles, we can have a half of a dozen, we can have a half of a mole, we can have a mole that's an actual fraction. Not fraction, decimal is what I mean. Okay, now let's look at this problem. I'm not going to do the math again. I just want to kind of show you how you could have taken another route on this. You could have said 1 times 10 to the 20th molecules of C3H8. Where could I have gone from here? Atoms. I could have said for every 1 molecule of C3H8, I have what? 3 atoms of C. And then I could have said, okay, well, for every 6.02 times 10 to the 23rd atoms of C, I have what? 1 mole of C. Do you see how you're doing the exact same thing mathematically? A multiplying by 3 and a dividing by Avogadro's number. So either way would have led to that answer. Do y'all feel reviewed on this? Easy stuff? Yeah? You seem a little bit happier than you were with nomenclature. Am I imagining that? It was the stress of the polyatomics, I know. All right, so let's go back to the next actual in-class problem, which was it was the chart. I'm going to look at the chart. Number 19. When you hear me go, that means it's on the test. All right, not exactly, but the concept, okay? So looking at this, let's look at the first one. We're going to solve, doing all the same calculations. We're going to solve for the missing parts. In an area like this, I'm not going to require that you show your work. I'm going to look at what's in the box. But some of you will need to do dimensional analysis to figure this out. So let's start with the first one. They gave us the formula, the molar mass, and the number of grams. The question is, how many moles? So, I'm going to kind of want you to write this down so you can figure it out. Some of you can do it in your head, but again, it's really easy to make a stupid mistake in your head. So if I have that many grams, how do I get to moles? What now? Molar mass, right? I have the molar mass. So for every 1 mole, I have 98 grams. And so my grams cancel. And so my moles, to save time, your mole ends up to be 0.00842. And I don't need to write units on that because it's in the column that's got units on it, so I'm okay with that. Now I got to fill in that last one. How do I get from this column to this column? Avogadro's number, right? So in this case, I'm going from moles. What do I have to do? Multiply. Not multiply, multiply. Get it? Oh boy. 5.07 times 10 to the 21 ends up being my answer when I multiply. Questions on the first one? Okay, and we know that the relationship between these two columns is the molar mass. Oh no, wrong column. Yowza, this column, molar mass. Okay, they give us this formula. What's the name of that? Chromium what? Not chromium? Chromium 3 oxide. We need to figure everything out. They give us the number of atoms, but that's all they give us, or formula units. So what do we do? Okay, what will that give us? If we divide by Avogadro's number, okay, go ahead. Well, I have it written down. It is 1.60 moles. Okay, that's nifty. But I need mass. So what am I missing? Molar mass, is that something I can figure out? Yes, hold on. All right, the molar mass is 152.00 grams per mole. All right, so I have the molar mass. I know the moles. How can I get to grams? Again, if you're struggling, write it down, 1.60 moles. I have grams per mole, right? So I know it's 152 grams. See, I messed up. That's why you need to write this down. 152 grams per mole. Moles cancel. So this is a multiplication. Again, you need to write these down if you need to see what's happening with your units. And when you get this, you get 243 grams. You guys okay over there? Okay. Uh-oh, we have an unknown one now. I know my mass, and I know my moles. I know how much a mass of a mole is. Mass of a mole. What is the mass of a mole? Molar mass. Is there a way I can figure out molar mass? Heck yeah. Mass, mole. Divide, right? Grams per mole. So when I divide grams per mole, I get 95.94. Pretending, let's just pretend that, oh, no, I don't get that. I looked at the wrong number, 119.33. Pretending that this is an atom, we're not going to pretend, it could be anything if it's a combination of atoms, but pretending that this is just an atom, is there any way to identify this? Probably not. 119. It's pretty close to 10. There's really no way to tell. So we're not even going to pretend we know what it is. But it is closest to the average atomic mass of 10. So now I have everything but my number of atoms. How do I get that? Avogadro's number times your mole, correct. So we get 2.87 times 10 to the 23rd. Okay, last one, we have molybdenum. What do I know about molybdenum? Correct, it's 95.94 grams per mole. I know the number of moles. I have 62.8 moles. How can I find grams? Well, I know it's 95.94 grams per mole. So if I multiply, I get I got 6030 grams. All right, now I need atoms. What do? Multiply by Avogadro's number, and I get 3.78 times 10 to the 25th. I'm going to go back and put in what I did here. Here I multiplied. Here I multiplied. I keep doing it in the wrong column. So here I multiplied. Here I multiplied. This is for the people at home. Here I divided. And then here I multiplied. Okay. Do y'all feel comfortable with mole calcs now? All right. We actually have 6 minutes to spare. That's pretty awesome because I didn't do very many. Do y'all want me to go back and do any of those other ones? Are you comfortable with this? Yes? All right. Have an awesome, awesome, awesome rest of your day.